Hi guys, trust you're all doing well today. Welcome to my YouTube channel, TPM Stack with Oluwole. Let's get right into it. In today's module, we'll be discussing security for revenue generating APIs. In our last module, we discussed system design where we look at scalability horizontally, vertically, where you're able to scale your system, scale your database. We also looked at the potential impact of even scaling your system and potential things you could also put in place or components you need to put in place while you are considering scaling your platform. But in today's module, we'll be looking at security. This is one of the most important topics, however, one of the least most talked about topic today. You've decided to open up your API. You've decided to open up your service. However, there are certain things you also need to put into consideration. Security. Security build trust, reliability build business. If your customers are not sure that their information is safe with you, then there's no point in them even doing business with you. So it's important for us to look at how can you ensure that you build an API platform that is secured enough, that can serve your customer, increase their trust in your product, and also assure them of reliability of your platform. Today we'll be looking at common API threats. As a PM or as a TPM building an API platform, one of the key things you need to understand or know for sure is that you're opening up your system, your infrastructure, your services, or your feature even to external users or consumers, be it developers, be it partners, businesses, fintechs, banks. However, that comes with its own downside, which is attack, and it opens up your system to potential vulnerability. As a TPM, your role here is to understand potential attack or common threat, and you're able to build a system that is reliant or strong enough to be attack resistant. Hence, we'll be discussing some common API attack patterns. We'll start by looking at SQL injection. What does this mean? This happens when an attacker inserts malicious SQL code into your input field. Don't forget, for every API requires an input field, so where you're able to instruct it or clearly instruct it on what it should do, fetch certain information, basically maneuver the database. We've discussed the core implementation of database. So when you're writing an API or sending an API, it's expected to do something within the database, either fetch an information for you, create a database, an additional information or a new information, update an existing information, or even delete an existing information. So an attacker clearly understands this. He knows that an API, for it to function well, is expecting an input field. So an attacker can basically impute a malicious input field. A typical example is this code we have here, where we have all 1 equals 1 dash dash. A typical example of what this code is expected to do is to return all the information, the information of all your customer in your database today. Is expected to return it to them. So an attacker knows how they can basically carry out some of this information. They're also able to write certain codes in a way that it returns particular information, probably your credentials, your national ID numbers. They're able to fetch all of these informations. Because they have all of this information, they're able to carry out malicious activities without your knowledge. We've seen scenario whereby an attacker goes to they sell your information, probably the attacker uses it or they sell their information. People are paying for loan they never borrowed. They are getting calls around loan repayment that they don't even know, they don't have an idea of what happened when they got that information. Because they've gotten your information, they've gotten everything that they need, they can usually use in impersonating you. They can go ahead and carrying out those information. So for you as a TPM, it's important for you to be sure to build a system that is reliable enough to keep your that customer information secure. Don't forget we had said security builds trust, reliability builds business. So you need to think security first to ensure your product is secured to serving your customer, and you also your own business reputation as well. So how do you prevent SQL injection attack? There are multiple ways of doing this, obviously, but we'll limit this to parameterization. What does this basically do? Instead of treating that query as a code, don't forget that an SQL too, you can write query. It sees query as a code that a computer can understand. So instead of treating those information as a code directly, parameterization helps you treat those information as a text or an input field. So it's not able to carry out certain information. A typical example of it is, and how do you know when a company or a brand has implemented prioritization? You've seen information such as a typical example of what we have here is Google www.google.com/search. Right, what we have here set, then you see a question mark and a Q. That Q there basically indicates that the company has taken into consideration SQL injection prevention mechanism using parameterization. So every other information you put after that, it takes that information as a text field, not as a code to be implemented. So in this way, you've prevented or built a system that is SQL injection tolerant. Secondly, we'll be looking at cross-site request forgery. What does this mean? This happens when an attacker logs into your platform and carry out an unintended action without your knowledge, without your approval. Now, how does this happen? Take, for instance, you probably open your web application on your laptop today and you have your bank application opened, right? And you decide to basically visit a blog. And on that blog, you got an ad to say spin to win. Unknowingly to you, that ad is sponsored by a malicious attacker. And you decide to probably try your luck and spin. So you click on the spin to win. What has happened within that space is the attacker now has access to your information. They're able to read your screen. They're able to read your laptop. They're able to also intercept certain things without your knowledge. A typical example is once they have all of those information, when you log into your system, there's something they call session ID today within the banking system or within most applications, where it's able to take in your section ID, look at the information you've stored on your cookies environment, right? And I think we've also talked about caching, where you can cache either on the client side. You can cache on the client side. You can also cache on the application or the server side. It's able to also read all the information you've cached on the client side, which is the application you're using. So it's able to look into your saved password, your I guess you must have also seen when you're trying to probably carry out a transaction and you're seeing your information giving you auto suggestion. Right, this is a function of Cardboard, and an attacker is able to use those information to their own advantage without your knowledge. They're able to carry out all of those information, carry out fraudulent transactions, carry out transactions on your behalf, take up loans. So it's important for you that even you as a user, beyond just the TPMs building platform today, as an individual, when you're visiting a website that you're not so sure of, is either you copy the link of that website and open it in incognito or don't open it at all. Because you never can tell if that link you are clicking is a malicious one that will open you up to attack today. How do you prevent this? We've seen scenarios where there are multiple ways of also preventing this, right? But one of the most common one is the bearer token. It prevents this by ensuring that authentication is set explicitly in the header, not automatically by the browser. I think I had mentioned earlier where I said your application today, your client side, you can have client side caching and you can also have application side caching. So it ensures that information is only sent by the header. So an attacker cannot trigger a request on the customer behalf without them knowing. Today we'll be looking at session hijacking. This is quite similar to what we just recently discussed. However, in the case of session hijacking, the user or the API builder or the platform builder are putting into consideration two things: session ID and token. They've also tokenized the request going out of the platform. However, an attacker can intercept this request to get access to the customer ID and the token. In the last one, we said we introduced you using bearer token. Now you've introduced bearer token, right? Now we are not saying an attacker can also intercept that to use those session ID and bearer token to make requests on your behalf. So how do you prevent this kind of attack? We need to implement something called refresh token. How does refresh token works, right? For each token being issued, it gives it an expiry date. So when the token expires, the token intercepted by the attacker the first time will automatically become invalid once this token gets expired. And for you as a TPM, it's important for you to ensure that your token refresh is implemented in a way that the duration is short and it can be done without even having to log the customer out of their platform. I bet you must have experienced scenarios or applications, you must have used applications where you're logging into the application and after some time, you automatically see session expired and it automatically logs you out. That's a function of token getting expired. So for you to be able to, for you as a TPM, it's important that you're able to build a refresh token implementation that does not necessarily log out the customer from their application. In this section, we'll be looking at API authentication model. However, I think it's important for us to also mention that each of these models, right, has its own advantage or disadvantage. It depends on the platform and the use case that will determine what to use and when to use them. So let's start by looking at API key. API key is an authentication method used to assigning an alphanumeric key to a developer, a business entity, or a bank or a fintech today. So think about it as when you're going into your app today. When you're going into your app, you provide probably your email address or your phone number, followed by your password or your access password or your access key. In the case of an API, because you're not able to impute typing, you don't have something that speaks to that password side of things. What we have is authentication. So on that authentication, you put in API key and you're able to embed on that key. There's an input field that will pop up and you put in the API key. An example of what we have here is the API key. You have it embedded there and you put it in the request. You add it to the request you're making to the API. So what this does is it looks at the request, and upon looking at the request, it looks at who is making this request. Do I have this information about this customer, or is this customer able to make such request into my application or even use my application in the first place? One of the key strengths of API keys is easy to implement, and it's also good for internal APIs. We had mentioned that every one of them are good, but it depends on the use case. So API key, when you're building a microservice where you have a large team and the team are able to interact with themselves, it's easy to basically, I think the approach for you to do here is basically build an authentication method that uses API key. However, it has its own limitation. Once an API key gets compromised, an attacker has the ability to make fraudulent requests without your knowledge. So what do you do around this? One of the key things you need to do as a PM is have an expiration date for each API keys where it's able to change. So the second one we have here is HMAC. What does this mean? This is a stronger authentication method that signs requests using a secret key. HMAC is more of like a cryptographic technique used for verifying integrity of the request and also authenticity of the request, using both key, whether the key or a secret key attached to it. So this kind of authentication method helps to prevent against replay attack. It also helps to prevent against request modification attack, and it's majorly used, and I think it's best used for payment kind of application, where you see them in those kind of application, you see bearer token, and in addition to bearer token, we also have secret key for you to, before you can even access the bank or the industry or the producer information. Lastly, we have JSON Web Token. It's also popularly known as JWT. This is the most used and most popular API authentication token used today. And how does this work? You log into your application. The server verifies your credential. The server generates a JWT token to you. The client stores that token, and with every request the customer sends, right, the JWT token is sent in addition to it or is sent alongside with it. The server generates that, it looks at that token, it verifies it, and it expires it. So how does this work? When you try logging into your platform, you input your email address, your password. Instead of sending that plain text to the server, JWT helps you convert that information into a token. So even when intercepted, the user is not able to make sense of it. However, the user is still able to hold on to the token to carry out certain transaction on your behalf. What's the advantage of this is it does not store any information. You don't even need to store any ID, both on the client side of the application or the server side of the application. No session ID is needed. It's also very efficient in when you're building a microservice kind of application, where you are opening up your application or your platform to both internal and external users. JWA token is very, very secured, right? Is a secure means of authentication in this case. However, like I mentioned earlier, the user can still decide to hold on to your token and carry out certain transactions. So it's important for you as a TPM to implement strong time expiration in terms of your token, like have it to be very, very short in that way. So even if an interceptor, an attacker has access to your token, they are not able to use your information for long, or if that's even if they're able to use it at all. Another important section is caching control strategy. In our previous modules, we've discussed how beneficial caching can be. It helps to reduce response time, also improve efficiency across, also improve performance across the platform. But if caching is not properly or carefully implemented, it can be manipulated by an attacker. If you remember, we had said that there's client-side caching and there's also the server-side caching. If caching is not properly implemented, it can lead to stale data, leakage of sensitive information, and break real-time user experience. So in this session, we'll be looking at how we can implement caching mechanism correctly. So let's start by looking at cache control. First, what is cache control? Cache control helps you to define how and where responses can be cached. So as an individual, say I'm providing you my API, I'm making my API available to you. Even in making my API available to you, I can also add certain instructions. So it's like you buying a car, and when you're buying that car, you have a user manual in that car, and you're able to see certain information around how to use certain things, when to change certain things, just to ensure that you are able to make the most out of that car and also not outchoose it to ensure good maintenance of that car. So we have different directive. I can choose to build an API and add certain directive to my APIs. I can make the directive public, private, no store. So what that means is I don't even want you to cache any of this information. No. Secondly, we also have max age. What this basically does is it helps you to put age limit, right, or age expiration to your cache. So instead of having to cache an information, and if you don't implement this, a cache can remain there forever. So it's important for you to ensure that you have significant or very short age memory for your cache, right? A typical example is where you have max age equals 300. This means that you can only cache this information for 5 minutes. In this way, the customer's information is not stale, and even when informations are being leaked, by the time an attacker has an access to it, they'll most likely not find any information in the system. Thank you for joining us today. Please let us know if you have any question in the comment section. However, please do share with your loved ones, and see you in our next module. Do have a great day. Bye, guys.